Hello everyone, welcome to this session out of this formula bonding and the nomenclature. We're still discussing about the empirical and the molecular formula. So far in our previous video, we are discussing the concept of these two, the empirical formula and the molecular formula. So today, let's further discuss about the empirical formula. The chemists, these are the people who study chemistry, are the ones that find the percentage by mass of each element in a compound by an experiment. Now, using this kind of information, it is then possible to find the sequence formula of that compound, and that's where the empirical formula comes up. Now, to do this, we shall also need to know the relative atomic mass of each element present in the compound, which is required to obtain the simplest formula of the given compound, that is the empirical formula. Now, to work out the empirical formula, you just need to know the masses of elements that they combine. Take an example, the magnesium combines with oxygen to form the magnesium oxide. So you have to know the masses of each element that form this magnesium oxide. Now let's see the various examples, various worked examples. Definitely we'll be talking about the how you can determine or what's the empirical formula and some of all the questions related to the empirical formula. Now this first example, an experiment shows that the 32 grams of the sulfur combines with this 32 grams of oxygen to form the compound sulfur dioxide. Now, what is its empirical formula? So our question is, we have to determine the empirical formula. Now, the solution is that first divide each mass by the relative atomic mass of the respective element, that is the lam of the respective element. Then this gives the ratio of the different numbers of atoms of each element that make up the compound. Now, again, you also divide each of these ratios by the smallest to get the whole number ratio. Now, we're going to see how it is displayed in the table in our next slide. Now, to give this, it gives the simplest ratio of the constituent elements possible. Now, sometimes you may not get the whole number ratio. Now, if this kind of a case happens, just round off the ratio to the nearest whole numbers. And finally, just write down the formula using the obtained ratio of the elements. Now start the following table as you're going to see in the next slide, and make sure you understand the procedure on how we've discussed all the procedures beforehand. Now, this is our table, and here, yes, you assess the elements, the relative atomic masses of the given elements, then the reactive masses, uh, and the reacting masses, then the mole ratios, then the relative mole ratio, then last you will get the empirical formula. Now the elements we have sulfur and the oxide, the relative atomic masses, sulfur is 32 and the oxygen is 16. Now the reacting masses is 32 and 32. Now the mole ratio is simply divided by the smallest, that is you divide by 32 and the and here you divide by 16. Now, the mole ratio, the relative mole ratio, get that is 1, and here it will be 2. Now, from there, the relative mole ratios are the ones which you are going to substitute to the simplest formula of the given compound. So, therefore, the empirical formula of the compound is this one, that is SO2. I hope it's clear. Moving on. Example 2, an oxide of carbon contains 27.3 percentage carbon. Now you are required to find the empirical formula of the oxide. What other element is also present in the oxide of the carbon, and how do we know that the percentage of this other element is 72.7%? Now, simply the solution is that, yes, in order to work out the simplest formula, we first have to divide each percentage by the relative atomic masses of each element. This it allows a comparison of the different numbers of the atoms of each element that are present within there. Now we get the ratio of each element with respect to each other as worked out in the table below, coming up in the next slide. Now to get a whole number ratio, we again divide each of these ratios by their smallest. Now the result shows the sequence ratio of the atoms. In this case, carbon atom to 2 oxygen atom. Now, simply the separation ratio, therefore it becomes CO2. And here is our table that illustrates the given explanations. Here are the elements. We have carbon and oxygen. The percentage in composition, there is 27.3%, and here it's 72.7%. Now, the mole ratio, you simply get that you divide by the lambs, that is the relative atomic masses of the given elements. So here it will be 27.3. You divide by 12, thereby you get that is 2.27. And also you take that the mole ratio we obtain by taking the percentage composition divided by the relative atomic masses. So also to the oxygen, it will be 72.7, you divide by 16, and therefore we get that is 4.54. Now, the relative mole ratio, you simply get by dividing by the smallest. So for the carbon, you get 1, and for the oxygen, you get 2. Therefore, the empirical formula of the compound is simply CO2. I hope it's clear with this example. You can simply just pass through them carefully and understand all the procedures just to obtain these kinds of things, the empirical formula and such. The last not least, the last example 3. A compound X is a hydrocarbon. It contains only carbon and hydrogen atoms. Now, 0.84 gram of X was completely burnt in air. This produced the 2.64 gram of the carbon dioxide, that is CO2, and the 1.08 gram of the water, that is H2O. Now, we are required to just find the empirical formula of the X. Now, solution. First step, that in CO2, just take 12 upon 44 of the masses of the mass of the that is carbon, and all the carbon that came from the eggs that we don't know the compound. Then so 2.64 gram of the carbon dioxide contains 2.64 gram. That is 12 upon 44 multiplied by 2.64 gram. Therefore, you get that is 0.72 gram of the carbon. And therefore, 0.12 gram of the hydrogen, you just subtract from 0.84 gram minus 0.72 gram, where we get that is 0.12 gram. Since we have deduced the weights of the respective elements in the compound, we can now work out the empirical formula as usual, as we've seen in the previous examples. Here's our table element, and we have two elements. There's carbon and hydrogen. The relative atomic masses, carbon is 12 and the hydrogen is 1. The masses we obtained for the carbon is 0.72, while for the hydrogen is 0.12 gram. Mole ratio, you divide by the given mass, you divide by the relative atomic masses, the lambs. So 0.72, you divide by 12. For the carbon, you get that is 0.06, and for the hydrogen, you take 0.12, you divide by 1, you get the value that is 0.12. Now, we finish up by obtaining the relative mole ratio, whereby you divide by the smallest. So from here to be 0.06 divided by 0.06, whereby you get 1, and to the other side 0.12 divided by the 0.06, you get 2. So the relative mole ratios will be substituted to the values, to the elements. Therefore, we get the empirical formula of the compound, that is CH2. I hope it's clear, guys. Thank you for listening. We've further discussed about the empirical formula. We've seen some various solved examples. I hope it's clear. You can pass through all of them to better understand them further and further, and to even look for more of the examples or just questions to understand more about this empirical formula. Thank you.